Okay, the last thing that I wanted to go over for today, and you know, there's not, I guess, a lot of material that we've gone over in today's lecture, but that's okay. It's okay to have easy days once in a while, because the only other things we went over today were things that you've already looked at, homework problems that you should already have tried. But anyway, I just wanted to briefly kind of let you know that we're gonna, starting next week, we're gonna start going into chapter 2 stuff. And chapter 2 is all about fractions. And so you'll have one item in your homework assignment today that has to do with fractions and representing fractions and things like that. But to kind of motivate that discussion a little bit, I just wanted to look at this page from your textbook. So this is page 21 of the textbook. So this is investigation 4. And it's just looking at all of the multiple different ways that you could represent the concept of 3/4. So I just wanted to go through each of these kind of briefly with you. So looking at number 1 here, I think this is a pretty obvious example of 3/4. It's just a standard kind of pie chart type thing. And the pie has been split up into 4 equal parts, and 3 of those parts have been shaded in. So the shaded area represents 3/4, 3 out of 4, right? And that's what 3/4 means. It means 3 out of 4, or it means the denominator of your fraction. It always tells you how many parts your whole is split up into, and the numerator tells you how many of those parts you're going to take, right? So we're taking 3/4 in number 1. You could think of number 1 as an area model. So you'll learn about different kinds of models for representing fractions. So area models, number lines, set models, things like that. And number 1 would be an area model, because the area that's shaded in actually corresponds to what 3/4 is. Okay, the 3/4 of the picture is shaded in. So that's an area model. Number 2 is also a pretty obvious one, pretty obviously 3/4, right? You've got 4 items, and you've shaded in 3 of them. So again, you've shaded in 3 out of 4 items. So 3/4 of the circles, in this case, 3/4 of the circles are shaded in. Okay, so that's the meaning of 3/4. So again, pretty straightforward. Number 2 would be more of a set model. Although it happens that the area here is, the area that's shaded in here is 3/4, but I think it's more closely like a set model. If you compare number 2 to number 5, you'll see that they're very similar. It's just that in number 2, the circle that's not, or sorry, in number 5, the circle that's not shaded in is a lot bigger than the other 3. This could still represent 3/4 if you're thinking of the circles as just individual items. So then you've got 4 individual items, and 3 of those items are shaded in. So this is 3/4. So number 5 is definitely a set model, but it's not an area model. Okay, because if you compare the areas of these 4 circles, you don't have 3/4 of the total area shaded in. You have maybe half of the total area shaded in, because these 3 circles are so much smaller than this one. So this is not an area model, but it is a set model, and it represents 3/4 just fine. Whereas number 2 is both an area model and a set model. What I want you to do now is pause the video and take a look at number 3. Number 3 is a really interesting one. And so what I want you to do is pause the video and see if you can see 3/4 in this diagram. Try to figure out at least 2 different ways to see 3/4 using this diagram. So go ahead and give the video a pause and try to do that. Okay, so I want to discuss some of the ways that you could see 3/4 in number 3 here with you. So one way that you could see 3/4 is if you go column by column. If you think about this column right here, it's a set model. you have 4 items and one of them has been shaded in. So this set model represents 1/4. And same thing with this set model. It also represents 1/4. And same thing with this set model. It also represents 1/4. So what you have then is 1/4 plus 1/4 plus 1/4, and that equals 3/4. So that's one way that you could explain the student's thinking, right? So maybe that's what the student was thinking when they wrote this down for their representation of 3/4. Another way that you could think about this is you could look at it in terms of the rows. So going down the rows, maybe if we sort of point out the rows that have a circle filled in, right? This row has a circle filled in, this row has a circle filled in, and this row has a circle filled in. So 3 out of the 4 rows have a circle filled in. So that's another way that you can maybe explain the student's thinking, right? I'm going to give you one more, but there are lots of ways to think about this. So one more way to think about it, and I think maybe kind of, well, I don't know. I was going to say an obvious way, but maybe it's not obvious to you. I don't know. But one way to explain the student's thinking is this. If you just count up the total number of circles, there are 4 times 3, 12 circles, right? 3 of them are shaded in, but that means 9 of them are not shaded in. So if you think about this diagram in terms of 3/4 is represented by the circles that are not shaded in, right? So then the circles that are not shaded in, there are 9 that are not shaded in out of 12 circles in total. And as you know from your previous exposure to fractions, this reduces to 3/4. So maybe the student is thinking of it as in terms of the circles that are not shaded in, right? So 3/4 in number 3 could be represented by the circles that are not shaded. Okay. So that's a few ways that you could use a diagram like number 3 to represent 3/4. It's definitely not the most clear, I think, diagram. I definitely prefer number 1 or even number 2. Number 3 is a little confusing, but potentially you could see what a student was thinking if they came up with that particular diagram. Okay, so I want you to give the video a pause again and take a look at number 4. Take a look at number 4 now and see if you can figure out how number 4 represents 3/4. So give the video a pause. Okay, so let's talk about this thing. It's really weird, right? Like, who would think to do it this way? Well, you might. By the time we finish with this chapter, you might kind of think of a diagram like this as a way to think about 3/4. But okay, so here's what it looks like. So it looks like we're starting with these 3 squares, but they're being split here, here, and here. And so if you actually push the gaps together, you actually get these 4 rectangles, right? This one, this one, this one, and this one. So you've actually got like 4 rectangles when you split it up that way. If you look at their areas, right, you've got 4 rectangles. And so for 3/4, once again, you have one of these shaded in. That means that the other 3, that means that you have 3 unshaded, right? 3 unshaded rectangles out of 4 rectangles in total. So this is another case where maybe the unshaded parts are what are representing 3/4. Maybe the student who drew this was thinking like, oh, I've got to get rid of a 1/4 of the diagram. How can I do that? Well, I've got 3 squares. I need to split those squares into 4 equal parts and then knock out one of them. So they're kind of getting rid of this part, and that leaves 3/4 of the original figure. This is an area model, by the way. So this would work for an area model. And as weird as this one seems at first glance, I think that it's actually a really nice way to think about the fact that 3/4 is the same thing as 3 divided by 4, right? That's another way to think about fractions, right? That fraction bar is the same thing as a division sign. So 3/4 is the same as 3 divided by 4. So I'm literally taking 3 squares and dividing them into 4 equal parts. So I'm making 4 squares out of 3 squares. And well, not squares, rectangles, right? I'm making, maybe a better way to say is I'm making 4 rectangles out of 3 rectangles. And the unshaded rectangles are what I get when I do that, right? When I take 3 of those 4 rectangles that I created. So that's number 4. There might be other ways to think about how 3/4 is represented by the diagram in number 4, but I think that's all I'm going to say about it for now. Number 5, well, I went back too far. Number 5 we already talked about. Number 6, well, this is a number line, right? So we've talked about area models and set models. This is obviously a number line model. If you split the space between 0 and 1 into 4 equal parts, then sure enough, right, this dot lands right on, this dot here lands right on, right, 1/4, 2/4, 3/4. We'll talk about the number line model for fractions a lot. We're not going to use set diagrams very much in this chapter, but we'll use number lines a lot, and we'll use area models a lot for our discussion in this chapter. So anyway, the rest of them are kind of interesting. So number 7, 0.75, that's just changing 3/4 into a decimal. So if you actually do the division, sorry, I did this the wrong way. If you actually do the division, 3 divided by 4, right? Well, 4 doesn't go into 3. 4 times 0 is 0. Subtract 3, add a 0.0, and bring it down. 4 goes into 30, 7 times, etc. Right? And you keep going, and you would get 0.75 out of that. So that's another way to think about 3/4. Number 8 is a good one. I went to a store to buy 3 bottles of soda. Or sorry, I went to a store to buy 3 bottles of soda to divide equally among 4 people. How many will each get? Oh man, that's so trippy. Give that one some thought. Think about number 8, because that's an excellent illustration of 3/4. 3/4 as being, again, 3 divided by 4. Because you're taking 3 bottles of soda and you're having to divide them 4 equal ways. That means each person is going to get 3/4 of one bottle, right? 3/4 of one bottle. So kind of an interesting thing. Number 9, how many 4s are there in 3? Or in other words, how many times does 4 go into 3? Or in other words, what's 3 divided by 4, right? Number 10, 18 out of 24. That's kind of like this one was 9 out of 12, right? 18 out of 24, same idea. So that's all I want to say for now about fractions. We're going to get into the weeds pretty quickly on fractions beginning next week. Like I said, you'll have a homework assignment. One part of your homework assignment is going to be to deal with fraction representations a little bit. So you'll be dealing with a lot of this stuff. And that's all I have for today. If I can figure out how to stop recording. Holy schmoly.